Hello, I'm Ali Reza, and I'm excited to tell you the story of our new paper on social robots and language learning. Gabriel Scanse is my co-author in this paper and my PhD supervisor. This study has been done under the ELADA project funded by the European Union. Language learning is a significant demand, and it's primarily learned through communication, and social robots are designed for communication. So there's a high potential in this area for them, and it makes them ideal language learning partners compared to other technologies. The branch of robot-assisted language learning has flourished over the last decade with the production of new robots. Most of the RAL studies are done since 2010. As a summary, most of the RAL studies show positive effect on language learning, focused on investigating word learning. Compare the robots with other technologies and forms of embodiment such as tablets and smart assistants, and finally focused on different aspects of robots' role appearing as a peer versus as a tutor. As the robotics technology advances, we need to gain a better understanding of these interactional dynamics between the robots and humans. And we found some gaps here. So educational robots are envisioned to be in homes or schools, and in these places, children might do the task together or alone or in presence of an adult or another child. In human studies, it's been shown that in presence of an adult, the children perform better in these tasks but speak less compared to presence of another child. And also, there's a difference in learning outcome between uh, doing a task collaboratively or alone. We were curious to know if the same effects are present in child-robot interaction. Specifically, first, how the number of learners and robots' age affect language learning outcomes. Second, does the amount that the children speak in such tasks affect their learning? And finally, how different ages of the robot is perceived by children. To find some answers, we developed an implicit word learning card game with the Four Hat robot based on the second language word learning theories, and it's played on a touch screen, and the participants are supposed to learn 9 new words. It is a sorting task that, given a scenario, you need to sort the cards on a specific order. Here you see an example of deck of cards. The player doesn't know the meaning of 3 of the cards. The robot appears as a co-player and is a native speaker of English. Together, the player and the robot are supposed to make the best order and have discussions around the position of the cards. If the player doesn't know the meaning of any of the cards, they can just simply ask the robot about it. And in the end of each round, the pictures along with the correct orders are revealed to the user. So we set up a between subject experiment and recruited 75 middle school students in Stockholm, and 69 of them finished the experiment successfully. We defined 2 conditions and should randomly assign the participants to these 2 conditions. First condition is the robot's age. We made 2 personas which only differed in face, voice, and hat. The first one is a child robot and the second one is the adult robot. The second condition is number of learners. So some participants played the game individually and some of them played it together or collaboratively. In each experimental session, we assessed the knowledge of the participants of the target words with a pretest, and then they did a familiarization session, and after that they moved to the actual game where they saw the 9 new words, where they did 2 stories randomly assigned in the order that they saw the stories, and each of them had 3 decks of cards with 3 new words each. And when they finished playing the games, they did 2 post tests. The first one is receptive test, which is the image matching task, and the other one is a productive test on filling the gaps on the target words. And if they had more time, they would fill in a qualitative assessment form. And a week later, they did a delayed post test of the 2 type of tests. Now let's have a look at the results. In order to understand whether the different ages of the robot by appearance was actually perceived as child and adult robot, we asked the participants after the experiment to assign an age to the robot that they played with. The participants answered with around 29 and 14 years of age for child and adult robot, which was a significant difference in this case. We tested the learning of our target words against the distractive words, and it showed a strong learning effect regardless of the condition. Our results by far outperformed the more traditional implicit word learning tasks such as reading. The speech duration of the participants, on the other hand, wasn't affected by the conditions and also didn't affect the word learning outcomes. Then, to test the main conditions of our experiment on language learning, the children who played the game alone with the robot had a significantly better productive word learning performance than the ones who played it collaboratively. Out of the 9 words, they retained around 1.2 words more than the collaborative group in both immediate and delayed post-test. We designed the behavior of our robot as a co-player, but nevertheless, the co-player could be anyone, could be a teacher or a classmate. So we asked the participants also which of these options best describes the behavior of the robot, or simply who was the robot to you. And the answers were really interesting. So first of all, the non-anthropomorphized option, which is mobile phone, is only chosen in the multi-party or collaborative condition, and we don't see it in the ones who played it individually. Also, rationally, we'll see the teacher option has been chosen in the adult group, and on the other side, the classmate is mostly chosen when the children played with a child robot. In conclusion, our study had 3 major benefits. During the game, the robot behaves completely autonomous and was only interrupted to answer the participants' questions. We used the implicit method where participants didn't know that they are doing a word learning task and nevertheless significantly learned new words. And also, the experiment was done inside the school, which is a natural environment. These all contribute to the validity of the results and made the situation more applicable in real world. Currently, we are working on a more in-depth analysis of the speech activity of the participants and their interactional dynamics, in addition to some of their behavioral cues. We have prepared everything in our OSF repository for replication. We encourage other researchers who are interested to use and replicate such studies with different conditions and samples so we get a better understanding of these concepts. Thank you all for your attention, and feel free to get in touch using the channels below for further discussion. I'll be happy to. Have a great day.